what makes this problem different than the previous one is we have like a 4 minus 2 root 3. So there's something being added or subtracted with the radical, and that does change the problem a little bit. What we're going to do is we're going to bust out a thing called a conjugate. And the conjugate is the thing where, like, well, I'll just tell you what this, if 4 minus 2 root 3 is my denominator, then that conjugate is 4 plus 2 root 3. We've seen these things before, right? The whole idea is that, like, it's the exact same numbers, but if we subtracted one, we're adding the other. And these are called conjugates. We've seen with complex numbers, and we've seen with radicals all the time. And the idea of these things is they're going to let us use that pattern that we've seen a couple times, that pattern that says if you take a minus b times a plus b, you get a squared minus b squared. So let's see this in action so that it's not quite so abstract. We have 4 minus 2 root 3. I'm going to go ahead and multiply both top and bottom of this fraction by this guy's conjugate. So that'll be a 4 plus 2 root 3, both top and bottom, keeping things balanced. Now, let's start with the bottom so you can see how this actually works. I'm going to do this the long way this one time, but in general, what I want you guys to see is when you're using conjugates, this will turn into 16 minus whatever you get when you square this. When you square this, you'll get a 12, because you'll square 2 to get 4. This will square to give you 3, and 4 times 3 will be 12. So this becomes 16 minus 12, which is 4. I'm going to show you the long way around this first time. So if I'm multiplying this bottom together, it is a situation where I've got a binomial and another binomial, so I've got to do 4 times 4. That makes 16. 4 times 2 root 3, that makes 8 root 3. Then I'll take this times both of these other guys. So this times this is going to be negative 8 root 3. Oh, that's cool. The radical's going to cancel. And then negative 2 root 3 times positive 2 root 3. Multiply these together to get 4. Multiply these together to get 3. So I get negative 4 times 3, which is 12. And then these cancel out, and I'm left with 16 minus 12. So the denominator here becomes 16 minus 12 is 4. And the top's going to become 7 times 4 is 28. 7 times 2 root 3 is 14 root 3. And now finally, because this guy and this guy and this guy, all these are divisible by 2, I'm going to go ahead and divide everybody by 2 and get a final answer of 14 plus 7 root 3 all over 2. It's kind of crazy to think that these two things are equivalent. They don't look anything alike. But, you know, get the calculator out. 7 divided by parentheses, 4 minus 2 root 3, close the parentheses. And then on this one, you do parentheses, 14 plus 7 root 3, close the parentheses, divided by 2, and you'll see it's the same crazy looking decimal. No way it could be coincidence, right? I mean, you did the math right. Good work.